Hello, everybody, and welcome to today's webinar with Elgin Industries on rocker arms of the ages. My name is Amanda Goyette. I'm an admin assistant with AERA, and I will be in the background today moderating today's event with my colleague, Rob Monroe.
Hey everyone, Rob Monroe here, and I look after membership and technical development at AERA.
One more thing from me real quick, just wanted to highlight for our members especially, we have a lot of corporate partnerships that our members can take advantage of, and I wanted to touch base real quick on UPS. We've had a partnership with them for many years at this point, and last year they actually changed their rates. So our members can now get a better rate than they have gotten in the past. However, you do have to call and talk to a representative to get those new rates. So if that is a program you have been thinking about taking advantage of, or something you are already taking advantage of, it's worth that call to 1-800-MEMBERS just to make sure you are getting the best rates. And the other thing to know on UPS is we do have a Canadian program as well. So if you are a member up in Canada, there are options there for you also. The other one I wanted to touch on is ODP, which is Office Depot products. Your primary focus may be in the back of the shop, but we all use paper, we all use, pens, pencils, you name it. So Office Depot is one of our newer, we've been with them for a couple of years. And this is just a great partnership that allows you to save a little money buying those supplies you need for your business anyways. You can sign up. I can get you a link. If you want a link, just let me know. And you can order online, or if you prefer to shop in person, you can actually use their app or get a little printout card that'll allow you to take advantage of those savings when you're shopping in the store. So if you want more information on that, feel free to reach out to me or just call 1-800-MEMBERS and let them know you're with AERA, and they will be happy to help you out. So with that, I'm going to hand things back over to Rob, and we'll keep on moving.
The other thing I want to highlight, we've already got 4 tech and skills conferences. We got dates for those set up for this year already. So March 15th, we're going to be out at Liberty Engine Parts, and that's at their new facility in Dallas, Texas. So that'll be in March. April, we're heading over to Tennessee. Choate Engineering. Cass over there has a really, really big, beautiful shop over there, and he's hosting this particular regional. And that's another one to go see. They'll be doing tours there. So that's on April 25th. Then the next one after that, we're actually heading overseas to collaborate with FTF Machines. So this company is a machine representative. They do Rottler and Comic and Surdy, but we are joining them over there, and we're going to collaborate, and we're going to have our Tech and Skills Conference over there. So for any of our European members and attendees that are on today, we'll be at that one, May 2nd and 3rd. June 20th, we'll be out at Goodson, out in Winona, Minnesota. They always put on a great party as well, and that'll also be a good one to attend. So that's on June 20th. So keep an eye. We do have a few more planned after that, but I thought we would just share what we've got going on here. And if you want any more information, just head out to our website. You'll see right on our main page there of our website, all the Tech and Skills Conference information is there. You'll be able to click on it and register for any one of those regionals that are coming up. So we look forward to seeing everybody there. And what we'll do right now is we'll bring Scott Steyer on from Elgin Industries. And Scott, he's a wealth of knowledge. Looking forward to this webinar, and he's going to talk to you all about rocker arms today. So Scott, how are you doing today?
Good. How's Rob?
Everything's good. I know you and I talked beforehand, and you're just kind of getting over you were sick there for a little bit. So I'm glad you're feeling better, because we were looking forward to this webinar for sure.
Well, thank you, Rob. Thank you, Amanda. Thank you, AERA. Welcome to this webinar. My name is Scott Steyer. For 7 years, I have done sales, tech, marketing, and other stuff for Elgin Industries. I am 4th generation in the auto industry, currently serving as president of my local chapter of the Model T Ford Club International, co-chair of the historic Elgin Automobile Road Race, which celebrates 115 years this summer. I'm also a purveyor of antiquated mechanical curiosities and a social media creator. My intention for this video is to offer information that is not readily available elsewhere, including historical context and Elgin's offerings related to rocker arms. Here in this etching, President Grant and the Emperor of Brazil are starting a huge 1,500 horsepower Corollas steam engine at the 1876 American Centennial Celebration held in Philadelphia. This engine powered all the machinery at the show. And although typically we think of rocker arms as the small inset photo shows, the scale of the historical context is quite large and storied. The history of rocker arm technology dates back to the dawn of civilization. 1.2 million years ago, prehistoric cultures began using any random wedge-shaped object as the world's first tool. Next, hunters and gatherers made a natural progression of that idea by adding a handle to the wedge to gain a mechanical advantage as leverage. This establishes the lever as one of the first simple machines, and its principles are functioning everywhere in our daily lives today. Illustrated here, a few thousand years after the agricultural revolution, in the late Neolithic era, was the first recorded use of the pedestal-style pivoting lever on a weight scale invented in the Near East. Compare this to the fulcrum-style rocker in the inset pick. Now the lever is no longer just a stick. It is part of a more complex machine. To put this period in perspective, this coincides with the invention of the wheel as a form of ground transportation. During the Bronze Age, machines continued to grow in complexity, here using the lever as a counterweighted rocking arm to lift the water between tiers of agricultural production. Note that the cranes ride on a shared shaft similar to the shaft-mounted rocker in the inset picture. Archaeological studies have identified notches on the building blocks of the Great Pyramids. These are attributed to the usage of levers during their construction and placement. The idea of multiple levers working together can be translated into the similar motion as the 6.7-liter Ford Scorpion rocker in the inset photo. Another few thousand years would pass until the first engineering principles were established that govern the physical world and its motion. It was Aristotle, the Greek philosopher, during the post-classical period. He began to classify simple machines, the first three being the lever, pulley, and the screw. Only a century later, Archimedes, a mathematician, scientist, inventor of much, predicted calculus and is arguably one of the leading scientists in classical antiquity. Regarded as the greatest mathematician of ancient history and one of the greatest of all time. He is one of the first to apply mathematics to physical phenomenon, working on statistics and hydrostatistics. One of his achievements in this area include the proof of the law of the lever, which we still use today to design rocker arms. This is the foundation that AI, artificial intelligence, uses as the basis of its calculations today. Skipping over the Dark Ages to the Renaissance, machines would become more complex. And as we continue to explore physics, such as sliding friction from Leonardo da Vinci, today we have options such as roller rockers to reduce sliding friction on the valve tip. Galileo has been credited with many significant contributions to physics and engineering, including as the father of modern science. If a simple machine does not dissipate energy through friction, wear, or deformation, then energy is conserved and it is called an ideal simple machine. In this case, the power into the machine equals the power out, and the mechanical advantage can be calculated from its geometric dimensions. However, all real machines have friction, which causes some of the input power to be dissipated as heat. We'll look more at this in a minute, as wear patterns on the contact and the fulcrum pivots, such as the pushrod cup, valve tip, and valve tip pad. The inset photo is a Chrysler 3.5-liter exhaust, which also includes lash adjusters. This image I had to include as a hold my beer moment in the history of levers as we develop machines to overcome obstacles. As you can kind of see, the guys up in the castle probably don't want to be talked to, but the guys on the end of the giant lever have figured out a way to get up there. During the Industrial Revolution, we shifted from harnessing natural energy to creating man-made energy to translate into mechanical movement. This early beam engine style steam pump bears the closest resemblance to our modern rocker arm, even though in this machine, energy is not yet being translated into constant rotational motion. During the Industrial Revolution, there were innumerable rocker arm variations patented for countless types of machinery. This slide are all examples of a Coriolis-style steam engine, originally patented in 1829, with successful variations in production by 1849. There are far numerous designs to discuss in the scope of this presentation, so I'll limit the examples to highlight some noticeable milestones of recent production. Excuse me. And as an aside, while creating the content, I've learned that imitation is the sincerest form of flattery, or something like that. Not long ago, I did a video on cam failures as the good of the bad, and the ugly. A couple days later, another YouTuber released a cam failure review video featuring the good, the bad, and the ugly. Recently, I posted a video of a pump jack with multi-ratio gearing, which currently has 9 million views on Facebook and 17 million on Instagram. Next, I knew at PRI, in a lobby space, a guy had a card table with a gear set, hand cut out of styrofoam. I don't know, it could be a coincidence, but if not, here's my next challenge to promote the minds of American innovation. I present the coreless engine. So looking at this, most steam engines are double acting. So in the center picture, you have your steam valve coming in from the top. The piston is going left to right. These are all rotary valves that are operated, synced together off of this central rocker arm. So as this valve opens, this valve is also opening. So intake is coming in here and exhaust is coming out here. As the piston moves from left to right, these two close and these two open. So now steam is being let in here while the exhaust is being let out. Upper left here, this is a compound. This is dual. The steam is being reused in the second cylinder, and then this one, of course, is a triple expansion. So 1, 2, 3 cylinders are all operated, synced together off of. Each individual has an individual rocker arm, but the shaft that's timing them together is all together. And then upper left is another variation of it, and then lower right kind of gives you an idea of the scale of the whole thing. And I guess probably the only other thing that I wanted to mention is that my first exposure to this was at the Northern Illinois Steam Power Club, where we have a full-size one like the one on the upper left. And then today as an adult, I have a small coreless in my basement that does function. Onward to internal combustion engines, including the Elgin connection. So diesel is credited as the first overhead valve internal combustion engine to have a camshaft, push rod, and rocker arms. After that, notably, there's a gentleman, Walter Marr, is credited with the first successful overhead valve engine. So early on, he had a bicycle shop about a block away from Henry Ford, which we all know his historical significance. 2 years after Henry built his quadricycle, Marr developed his own overhead valve engine and put it in his own cycle car, which caught the attention of Buick. So he went to work for them for a couple of years, but then split off on his own and came here to Elgin, Illinois, to build his Marr auto car, which there's at least one remaining here that we had in our own concours a few years back, as well as a few other historically significant cars that Marr worked on. After he made the cars here in Elgin, Illinois, which was the first successful overhead cam engine, Buick brought him back, which he continued to develop engines for them, which of course they used overhead valves for almost all of their production going forward. And then by 1909, 1910, he headed up the Buick's entry into the Indy 500, which was driven by Louis Chevrolet. Next, I present a specific case study of industry significance. Oldsmobile is credited as the first mass-produced successful gasoline automobile engine in 1901. At that time, the Dodge brothers were still in the machining and foundry business and were awarded the contract to make the transmissions for Oldsmobile cars. By 1902, Olds had developed the first progressively moving automobile assembly line. Next, in 1903, Olds competed the first automobile race at Daytona Beach. In 1905, Oldsmobiles were first to compete in the Transcontinental Race, completing a journey from New York City to Portland, Oregon. Olds were also the first cars to have standardized components. 3 cars were driven to Washington, D.C., disassembled, swapped the pieces around, reassembled, and drove away. The big picture on the right-hand side, you can see that the carb is the brass piece on the right, and you can see the pipe thread exhaust on the left. The cam runs perpendicular to the crank, driven off of a helical gear set. There are two lobes that interface directly to the rocker arms with roller follower tips. Note that the intake is a traditional center pivot, and the exhaust is wishbone shaped, straddling the intake and pivoting out at the end. So again, you may have seen some wild, innovative looking overhead setups in recent years, but in reality, most of the technology goes all the way back to the beginning as seen here. Another little reference to it's important to note that Henry Ford is attributed to many of Ransom E. Olds' achievements, when in reality Henry Ford only approved on them. It was later in 1908 that his Model T Ford was introduced, equipped with a flathead four-cylinder engine without rocker arms, and 5 years later in 1913 he improved the assembly line by making it continuously moving and synchronized. A common link between most early car companies is that Dodge brothers were supplying the many mechanical components to all of them. Horace and John Dodge would begin manufacturing their own cars in 1914. Pictured in the lower right are Henry Ford at the wheel of his 999 Racer, with Dodge's pictured standing with him. John Dodge served as vice president of the Ford Motor Company, and Horace's middle name was coincidentally Elgin. So no relation to Elgin Industries, but it's just kind of interesting that Horace's middle name was Elgin. The controversial topic of Chevys powering Fords is also a significant moment in the history of rocker arm history. The Chevrolet brothers were racers in every respect. Highlights include, as I already mentioned, the oldest brother, Louis Chevrolet, piloted the Walter Marr Buick Indy car in 1909-1910. He and middle brother Arthur and William Durant founded the Chevrolet Motor Company in 1911. Then in 1916, Chevrolet brothers started the Frontenac Motor Corporation as an independent company to build high-performance race cars, which led the younger brother and racer driver Gaston Chevrolet to win the Indianapolis 500 in 1920, driving one of their Frontenac cars. In the 1920s, they expanded their offering of speed parts to include a variety of overhead valve, single overhead cam, and dual overhead cam aftermarket cylinder heads to fit the popular Model T Ford flathead engine. That said, Chevrolet engine technology has been making Ford cars go faster for over 100 years. And although someone could argue that Frontenac isn't a Chevrolet branded part, I will add that in 1928, historically, officially, indisputably, the Chevrolet production cars were built with a four-cylinder overhead valve engine that had the same cylinder spacing as that of Ford. Home-built pre-hot rods, jalopies, and gouge jobs were fitted with adapter plates to mate the 1928 Chevrolet overhead valve head to their Model T and Model A Fords in an effort to boost power. This trend still continues today with small block Chevys and old Ford hot rods and LS Swamp Fairmonts and Mustangs. The car pictured here was in our collection for a number of years, so I've had the privilege of waxing and driving it. Today pictured here, it resides in the Museum of American Speed at Speedway Motors in Lincoln, Nebraska. Finally, to the Elgin part. 130 years ago, the south side of Chicago was an affluent and glamorous place. In 1893, it hosted the World's Fair and Columbian Exposition, and in 1895, it hosted America's first automobile race. Situated in the heart of this era, on the shore of beautiful Lake Michigan, was the elegant Hyde Park Hotel. The garage of this hotel is where Martin Skoke Sr. would begin his lifetime career in the automotive industry. Skoke had already been working in skilled trades of machining and electrical. Next, he joined the Excelsior Company, manufacturing engines for Stoddard, Dayton, and Maytag automobiles. Yes, it's the same Maytag that still offers washing machines, and in fact, the first Maytag washers were equipped with a two-cycle gasoline engine. Maytag did not develop the engine. They just bought an already successful engine that was made in, you guessed it, Elgin, Illinois. The building that housed several of these manufacturers is where Martin Skoke started production of the Elgin Machine Works in the same era. I do also have a late production Elgin Comet engine in my personal collection as a connection to the current Elgin Industries. By 1927, Skoke's Elgin Machine Works was so successful that he was able to build his own new purpose-built factory. After the 1928 Chevrolet four-cylinder, they introduced a six-cylinder in 1929. These 1929 rocker arm shafts were the first rocker components for Elgin to catalog. Rocker arm shafts were a natural fit to our existing production of piston pins. We would continue to introduce additional rocker arm components to the aftermarket, such as bushings and lash adjustment hardware. By mid-century, Elgin's rocker arm offerings had grown into a full line. We continued to support popular older platforms as well as supply rocker arms for late model engines. As engines switched from mechanical valve tappets to hydraulic lifters, the older design of cast rocker arms with lash adjusters were replaced by the one-piece stamped steel rocker arm, pictured in the lower right. Elgin partnered with Sanco Automotive Limited in Canada in 1982. We bought out the aftermarket division of Sanco and moved it to the Elgin manufacturing plant in 2006. Next, we bought out WH Industries rocker arm business in 2012 and moved that to the Elgin plant. This expanded both the performance and stamped rocker arm business for OEM, Tier 1, and aftermarket. Today, two of Martin Skoke's grandsons are here every day running the company and this factory. We have been owned and operated by the same family in the same town for 106 years. In the upper left picture, 170 co-workers enjoy Elgin Industries' 100th anniversary in 2019. Lower left is a portion of our in-house stamping facility. On the right are some examples of rocker arm production. We begin by buying large rolls of steel. We have those rolls slit down into manageable widths, and from those rolls, we first stamp out discs. An example of this is in the top left of the photo. Additional stampings continue to form the finished part. The lower right is a Chevy rocker before it receives its roller tip. In 2015, the small block Chevy is officially 70 years old. Elgin offers several variations within this most popular platform. The 1:5 ratio with stock slot are stock replacement. 1:6 ratio gains lift, but duration remains the same. 1:6 also increases valve speed, so higher spring pressures are required to compensate. After around 0.450 lift, a long slot is recommended. Each is available in 3/8 and 7/16 stud slot sizes, with and without guide rails, and several finishes for OE replacement and performance aftermarket. Guide rails do add additional side load on the valve compared to using pushrod guide plates, but all rockers go through the standardized OE heat treatment. Stamped rocker arms are available from Elgin, boxed, in singles, or in bulk. As I just previously mentioned, rocker arm shafts have been one of our oldest offerings for rocker arm components. Today, the Mopar shaft-mounted rockers are available individually, with or without rubber plugs, and in sets with shafts for either one head or one engine. AMC rockers are available in pairs with fulcrum pivots and bridges for one cylinder. Oil deflectors are situated per OE specs, as are stamped rockers for other engine platforms. The LS engine powdered metal rocker has been applauded by industry engineers as the most perfect rocker ever conceived for OE production. I'm not an engineer, but I have heard arguments for and against roller tip rockers. A roller tip is a lot of weight to have hanging out there articulating, riding up and down on the valve. The gains by reduced sliding friction are negated by the additional valve train wear. So for longevity, the OEs don't use roller tips. And these LS rockers are easily achieving 1/3 of a million miles. Pictured at top are Gens 3, 4, and 5 LS. Bottom row is Chrysler 3.5s, and then the classic GM 1.6 and Ford 2.3 followers. You may have noticed some new engine applications with Elgin. Pictured here, upper left is the 6.2 Ford. Next, in the upper right, is the follower that is shared between the 3.5 Duratec, 3.5 EcoBoost, and 5.0 Coyote. Lower left, the LS appearing rocker is the 7.3 Godzilla. Next to that are the 6.4 Ford Power Stroke and the 6.4 Ford Godzilla. No, I'm sorry, 6.4 Scorpion. These two diesels are OE replacement that include the rocker pivot ball material being made to the correct spec. Other aftermarket rockers are wearing prematurely due to the rocker pivot ball insufficient material. Another debate I'll address is pivot balls with and without grooves. The idea is that the grooves allow oil down around the ball for additional lubrication. The OE argument, that's original equipment engineers, is that the grooves allow the oil someplace to escape. In single rocker kits, we offer separate part numbers for either grooved or smooth balls. For performance parts, we only offer grooved. Rocker arm studs are available in a variety of sizes for OE replacement and aftermarket performance applications, matched to powdered metal fulcrums and pivot balls, with the pivot balls also being dichronite coated. Nuts and posi locks are available in standard heights as well as low profile to fit beneath valve covers. To complement Elgin's camshaft lifter kits, pushrod and rocker arms go hand in hand. Together, these two kit part number categories cover half of the valve train for an engine. Combined with specific valves, springs, and head components from Elgin, gets you a solid setup for your engine build. These kits have been popular for decades, including Gen 3 and Gen 4 LS engines. From OE replacement onward to Pro Stock performance, in addition to Elgin's full line of OE replacement valve train, we also supply options for the performance engine builders. The black ice cryogenic treatment, which we started using on our own cutting tools and heads because we are largely a cutting company, cutting and grinding. We know that we get longer life out of our equipment when we apply this to our own stuff, so we've expanded to apply it to automobile parts. So these rockers, actually all the parts, all still begin with the same OE base carbonitride heat treat. After that, we put them in the cryo freezer to about -300 for about 3 days. And what that does is that gets us the maximal obtainable hardness from the heat treat base materials. It also gives us maximum material and geometric stability and uniformity, maximum wear resistance, and elimination of material stresses with mass changes. These are available with and without balls and nuts, only in sets of 8, and include multiple applications of Ford, Chevrolet, and Pontiac. So these are popular with short track racers, specifically those that rebuild their engine every 1, 2, or 3 seasons. The nitro stock appearing also get that same base OE carbonitride heat treat, but then get an additional gas nitride treatment, which is an advanced surface hardening for increased wear and resistance. These are long slot only, 3/8 or 7/16 slot size. They do include balls and nuts available on sets of 8 on a skin board or sets of 16 boxed, specifically for both small block Chevy and big block Chevy. These rockers are popular with short track racers that rebuild their engine not every 1, 2, or 3 seasons, but every 1, 2, or 3 races. What this is a slick coating on the outside for less resistance, which does translate to a faster part. But once you burn through the coating, the stock component is still underneath. The next step up in performance after the coatings, after the treatments, are roller tip rockers. Again, the same base OE carbonitride, long slot only. These have an H11 tool steel roller and pin, 3RA precision ground roller finish, includes balls and nuts for increased horsepower, reduced tip rocker friction, reduced stud flex and failure, ensures smooth valve train and operation and stability. Available in sets of 8 or 16, and we make these for both small block Chevrolet and Ford. These are direct drop-in replacement for power gains in performance engines. These are not self-aligning. If you're concerned about material flex in the body of a stamped rocker, then the stainless steel rollers are the next step. These are available only in sets of 16 with posi locks and are reported to have 15 to 30 horsepower gains. Choose the appropriate studs and use with guide plates that match your pushrod diameter. These have hardened steel pushrod cups and full needle bearing trunnions. These are designed for high RPM with no deflection, increased durability, and quicker response. The large roller tip is held in with a C-clip for the trunnion and are good to 600 pounds of spring pressure. Again, these will need guide plates and then, of course, hardened pushrods. Elgin offers one-piece thick wall pushrods in 050 to 025 increments for all popular applications. The other SSRs that we have that are becoming popular, of course, the LS engine has been the talk of everyone for the past 20 years or so. So not only do we offer the previous stainless steel rockers that are stud mounted that use guide plates for the LS engine, but we also offer drop-ins for the Gen 3 and Gen 4 engine platforms. You use this with a stock rocker spanner. These are made out of 17-4 pH polished stainless with a CR40 heat-treated roller tip, good to 400 pounds of spring pressure. These, of course, share the same extra large full needle trunnions, the C-clips on the trunnions. These are held in place by stock 8mm bolts, which are included. They're available in both the straight and offset rockers, which would translate into both the Gen 3 and Gen 4 sets. And this wraps up the catalog review part of Elgin's rocker arms offerings. Next, on to failures. These are the issues that I have been asked over the tech line in relation to Elgin's offerings. The saddest one is when guys call after their fresh build and they have a sheared rocker arm stud and they think it's the fault of the stud, when in reality they put in a higher lift cam and they did not put in long slots. So if the stud makes contact with the inside of the rocker, it's guaranteed to shear. That's just how it's designed. If you have a problem with that, call GM, because they're the ones that figure that out. Another thing that's easy to overlook but compensate for is that if the push rod cup if you end up with contact where it ends up wanting to put pressure on the side of the rocker, and that can be solved by going with a push rod that has a 210 radius end instead of just a regular 180, that the balls are actually curved all the way beyond just 180 degrees. Retainer contact, of course, is something you should always look for. And people call and ask, what is the retainer clearance? And I always say, well, the engineers always tell me that if you were to go with a tapered spring, that would change, which is true. Same thing with different RPMs and different valve train geometries. Valve tip uneven travel, of course, adjusts the push rod length. That's talking about the travel as it articulates up and down from the exhaust side to the intake side. Excuse me, I'm recovering from a cold. That's the random cough. Valve tip side to side is, of course, controlled by either push rod guide plates or by using a self-aligning rocker if you have that available for your application. If you notice cracking around the opening of the slot, that might be because of excess spring pressure or lack of oil. Again, with push rod penetrating the rocker, also you can sometimes have the rockers contact the rocker box cover. So they make tall valve covers for that purpose. We kind of talked about if you need a stock appearing rocker but need it to be a little bit better, then that would either be the black ice or the nitro. If you're noticing that you have stock rocker arm flex in the stamped rocker arms, you can go with the stainless steel rockers. And if there's any fatigue, you should always just replace it. These are all, of course, just applicable to Elgin's line of OE replacement and street performance engine parts. Beyond what we offer for full race applications, you have a variety of options too, including trunnion upgrades, shaft-mounted rocker arm systems, stud girdles, extrusion aluminum bodies, and more. However, those are all outside the scope of Elgin's offerings. Pictured here are some used rocker arms from a reman. It's become very common for engine rebuilders to reclaim and reuse used rocker arms, push rods, and even valve springs. And after countless workload and heat cycles, the case depth will wear and cause a weak point. Valve springs will especially fatigue blindly until their unannounced failure. So some of the wear patterns that you can look at here, I brought back a couple of these and gave them to our labs so that they could show you some stuff here. One of them is the valve tip pad contact area. Has worn through the case depth hardness, and that the softer core material is wearing at a faster rate. The push rod cup area will wear as a step, creating a weak point for the cup to fracture and may puncture the rocker arm. And of course, the pivot action will wear into the case hardened surface and produce a step, again creating fractures. And that step is visible on the rocker on the upper left in this picture, which you can also see here. After they've been, this is the same rockers from the last slide that we have cross-sectioned, mounted, polished, and inspected for wear. In our lab, every day we do this to new parts production to inspect material structure, heat treat case depth, and other tests. While examining used parts, we can confirm that they are a ticking time bomb with imminent failure. The cost savings is negligible compared to the premature engine failure due to one of these compromised components. Then this happens. You can see the fracture area around the punctured push rod, as well as the high polished step from the pivot ball wear. There's also some funky stuff going on the valve pad, where you can see that it lived its life in one spot and then it shifted to the other. Not sure if that was because it was starting to side load on the guide and the valve stem tip. But for additional info and pictures on engine failures, these are thoroughly documented in the Failure Analysis Manual produced by the AERA. So finally, let's wrap up with the About section of Elgin Industries. So these are all pictures of stuff that we've been involved with. As I kind of said, Elgin was founded by Martin Skoke in 1919 as a automotive manufacturing and distribution company in North Central Illinois. We have been family owned and operated for 106 years. We are a manufacturer, primarily the building where I'm at. We do the push rods, piston pins, rocker arms, king pins, and other related components. A lot of stuff also has to come here for final heat treat. We have about 170 employees on a daily basis, and we're a fully integrated manufacturing facility. So raw steel comes in the left-hand portion of the building, gets processed all the way through, and then finished box material comes out the right. As a Tier 1 OEM supplier, we are, as I said, primarily internal engine components and also suspension. We have all of our ACES and PIES data. Vehicle applications are automotive and commercial. Packaging is always something we've been proud of. We started our own box factory, I think, back in the 50s. So we do have a lot of different customizable packaging. Our quality certifications is something that sets us aside from other aftermarket-only companies because we do get audited. We actually have to we employ a team of our own auditors that keep track of everything year-round. That way, when it does come time for audit, that we are able to have all our ducks in a row. The most difficult one is the Ford Q1. That's pretty much every other certification combined. And that's because alphabetically, our primary customers are Chrysler, Ford, General Motors, Harley-Davidson, John Deere, Mack Truck, Navistar, Polaris, amongst many others. We make engine components, cams, lifters, bolts. We offer a variety of other oil pumps. Again, this is the largest fully integrated pushrod manufacturing facility in the world, the largest fully integrated stamped rocker arm manufacturing facility in this half of the world. We're known for a lot of our timing and components, as well as a variety of valve train for both automotive and heavy duty. Here's just a variety of some of the ads we've been running lately for some components. Some things we've been proud of is the LS engine lifter guide sets for both the Gen 3, Gen 4, and Gen 5, as well as Ford OE replacement diesel components, super finished valve springs. Again, of course, the pushrod capital of the world, and we're world renowned for our sloppy camshaft line of performance camshafts, and as well as OE replacement. So again, some of the stuff that we are the deepest in with on steering and suspension, a lot of heavy duty, a lot of kingpin sets come out of this building. It's one thing that we're very well known for. Catalog, 35,000 SKUs available 24 hours a day, including all the tech info available at any given time. Core competencies, grinding, heat treat to a Tier 1 level. A lot of different manufacturing techniques, a lot of big equipment out there. The floor has steel in it. I've always been kind of fascinated that we blended when we purpose-built this factory back. This is our third factory back in about 40 some odd years ago. They poured steel into the mix of the floor. We have our own in-house heat treat, captive, which is something not a lot of other people can brag about. The picture on the left, you'll see that those are camshafts going into some sort of form of carburizing. So there's no such thing as a soft cam. They go in big batches. To the right of that, those are kingpins going through induction heat treat. That would be the same type of process that camshafts go through, but we're not going to show you the camshaft heat treat because could be other people watching. And then the lower right is the Holcroft. I call that a pizza oven the size of a pole barn. It's huge. It has an endothermic, preheat, gas, all sorts of really cool stuff that's very hot. Those are push rods coming out of there in that picture. Grinding, something that's safe to share with the world is a piston pin. I believe that's a John Deere. And then there's also super finishing in this picture too. We have a lab, as I kind of talked about before, with a lot of fancy tools and machines and people that know how to run them and are able to produce data down to, 500 thousandths of an inch. thereabouts. Yeah, something that sets us apart from, I guess, the rest of the industry is that we're one of those that makes parts for everyone. So if you have any questions, suggestions, comments, or concerns, please visit our website where you will find PDF catalogs, links to YouTube tech videos, our catalog of 35,000 SKUs, and even sign up for our newsletter for the latest and greatest innovations from a 106-year-old American auto parts company. Thank you.
Well, Scott, no, thank you. That was excellent. I really enjoyed those slides, especially at the end, giving that little bit of a sort of a factory tour for those that don't get a chance to get into to see your facility. I've been lucky enough to be there and to see it, and this is an absolute first-class facility for sure. You get to see it every day, so you're lucky as well.
Yeah, thank you.
We do, yeah. We do have a couple questions that have come in. The first one is they're asking, does Elgin have any custom production, like specifically doing anything custom and related to camshafts or rocker arms?
Not particularly. For us to do anything, it's got to be it can't be one at a time, I guess is what I'm getting at. It's got to be a pretty good sized batch. That is something that we could consider maybe on the rocker arm side. Cams, we could probably put you in touch with the right people that could probably be the next step before you get to us. For us to do a batch, you're looking at some tall numbers. But if it's for development, please reach out to the website. That email address right there, I'm included on that. There's several people that get that email, the sales@elginind.com. If it's something you're looking at, please reach out. We'll be glad to. If it's not something I can take care of, I can connect you with the people that can. So yes, I guess is the answer, but not necessarily a complete yes. So.
Okay, perfect. How do you go about and the questions come in is how do you choose the correct rocker arm for the application? What's the best way to go about that?
Well, if you have the sample, of course, that you can compare it to, visual is going to be a big first step. To see if you need to replace it, if it's worn out, and what the characteristics are of what it looks like. But beyond that, probably the first good step would be to just to look in the catalog, and I would emphasize that there's probably several variations for the newer stuff that include VIN brakes or different year brakes or variations within a single engine platform that may have had a long run, is to just not necessarily choose the first one that we have in the catalog, but to continue to scroll down and make sure that there might not be a different version that slightly has a slightly different variation that might be exactly what you're looking for. But if you're having difficulty navigating the catalog, then please give me a call. Call that 800 number, hit extension 394. That'll get you straight to my desk, and I'll help you get squared away. I'll help you figure out exactly what it is if you have any questions.
Okay, super. We've even got somebody that enjoyed the webinar so much they would actually like to come work at Elgin. So we've got the question is Elgin offering any remote sales positions? So maybe you could sort of point them in the right direction and let them know who to get a hold of or who to contact there.
Yeah, that I don't know, but again, reach out to us at that sales@elginind.com. I don't know that we have anyone remote, but I think that there might be some stuff on the careers section of the website that might be kind of in that realm. If you wanted to follow the prompts when they get to the careers section on the website, that would probably be a good first step because there is a few jobs on there right now, I know. And we're always hiring just basic, CNC operators, distribution of putting parts in boxes, etc. That's constant, as is everyone in not just this industry, but I think that's more than just nationwide right now. So
sure, no, exactly. You made reference to both the nitro and the black ice rockers. So the question is they seem very similar. And which is more popular? Which is the one to go, or how do you determine which one is the better one?
Well, by volume, they are pretty close, but the difference is, I suppose, that the black ice is going to last longer, so we're moving more of those to more people versus the nitro. if you're running really high spring pressures and you're really looking to be out front as a leader in every race, then nitro is definitely a faster rocker until you burn through that coating, and then you're back to a stock rocker underneath. So we are selling a lot of those also, but we're selling it to fewer people because they are, as soon as they burn through the coating, they throw it out and they put another one on. But that does give them an advantage over the competition by using that nitro rocker, which is faster, even though the black ice rocker is longer lasting. And that's across the board. That's why we have black ice camshafts. We have black ice push rods. We have a lot of different components available in the black ice line. So,
well, Scott, again, we really appreciate your time. I know it takes a lot of time to put into these webinars and all the slides and everything, and we do appreciate that you did that. I hope you're feeling better. Hopefully, you're not didn't take everything out of your voice. So when you go home tonight, you're not having to not talk to your wife at all. But again, thank you very much. And like I say, what we're going to do now, everybody, is we're going to go back to Amanda, and she'll wind things up.
Okay. Thank you, Rob. Thank you, Amanda. Thank you, AERA.
Thanks again, Scott.
All right, real quick, you guys, in case you don't know, all of our webinars do go out to our YouTube channel. So if you go out to YouTube and you search AERA Engine Builders Association, you will find our page. And there's a lot of great content out there already. We've got almost 60 technical webinars, some business webinars, tutorials for our Process Pro software, and much more. So feel free to check that out, and don't forget to subscribe so when we post new videos, you do see that those are there. And then lastly, just thank you for taking time out of your day. We know how busy you all are, and we appreciate you taking time out to watch these webinars. And if you need to get a hold of anyone at AERA, you can reach us at 815-526-7600, or feel free to shoot an email to myself or Rob. You'll see both of us have our email addresses there. So once again, thank you very much. We appreciate your time, and we hope you have a great rest of your day.